Hello and welcome. My name is Mark Johnston. I'm the editor for Industrial Automation Asia. Today I'll be moderating the webinar Achieving Digital and Operational Excellence in Smart Manufacturing. There will be a Q&A session at the end, so please click the Q&A tab below to submit your questions for the Q&A session later. Before we get into this particular topic, I'll provide a brief introduction on IA and what we have been up to recently. IA has been around since 2001 and is considered the premier English language publication for industrial automation in Southeast Asia. In 2020, we achieved over 1 million page views and close to 80,000 users. During the height of the COVID-19 pandemic, we launched a digitalization roadmap to help manufacturers better understand their options as digitalization becomes an investment priority to support manufacturing resilience under the strain of an unprecedented crisis such as COVID-19. The pandemic has created significant disruption in the manufacturing industry. However, it is evident that organizations who have invested in smart manufacturing and Industry 4.0 technologies have fared better. While there is light at the end of the tunnel, the pandemic is still a reality and will be so for the foreseeable future. A recent McKinsey survey of manufacturers in Asia found that 45% of respondents struggle with a sudden material shortage due to the pandemic, while 41% experienced a steep drop in demand, and 30% suffered worker unavailability due to the COVID-19 restrictions. In light of this, companies such as Azbil, Vertiv, and Schaeffler look to mitigate many current and future problems manufacturers face during and after COVID-19, helping them to streamline and navigate the complicated technological landscape. So without further ado, Jin Watanabe, Regional Technical Specialist at Azbil Corporation, will start the webinar with his presentation on realizing smart factories using IoT and AI. Over to you, Jin.
Hello, everyone. I'm Jun Watanabe from Azbil Corporation. I work at the Strategic Planning and Development Office for Southeast Asia in Singapore. Azbil provides field instrumentation, control system, solutions, engineering, and maintenance services to help optimize equipment at factories throughout its life cycle. Today, I would like to talk about realizing smart factory using IoT and AI. As you may know, the use of Industry 4.0 technologies like IoT, big data, and AI are accelerating by the day. Industry 4.0 realizes digitalization of all instruments for improvement of safety and productivity in manufacturing sites. That realizes the smart factory. So how does your factory changes with Industry 4.0? First of all, let's look at the current plant operation monitoring and its issues. Normally, to operate a factory safely, we monitor and operate with process control system and patrol inspection regularly to ensure productivity. Azbil calls this traditional monitoring operation with process control system and patrol inspection first eyes. But there are some issues with first eyes. Firstly, it's impacted by differences in operators' ability level. That may cause decreased level of situational awareness. Secondly, with the retirement of experienced operators and future decline of working population, there will be loss of skill and operator will have to be done with fewer people than now. Thirdly, with aging or insufficient maintenance of equipment, there is danger of equipment malfunction and incidents. If this continues, the workload will increase, critical alarm will be overlooked, and we will not be able to rely on operators or for improvement safety and productivity in plant. To solve the issues that I just mentioned, Azbil recognized that in addition to first eyes, second eyes, and third eyes are needed to increase the human situational awareness abilities. They help us improve site safety and productivity. We define second eyes is the implementation of optimal maintenance based on equipment diagnosed by high-performance sensors. Third eyes is detecting symptoms of abnormality and predicting future changes using AI and big data. They inherit and transcend the wisdom of experienced operators. By using second and third eyes, there will be an early awareness of abnormal situations and decision-making will be possible. For realizing a smart factory with second eyes, we detect irregularities in control valves and positioners at an early stage by control valve diagnosis. With third eyes, we provide the online anomaly monitoring system, which runs the neutral state of plant with fuzzy neural network. This detects and gives forewarning of any irregularities. And with early warning system for time series data, we also are able to forecast and visualize future fluctuation in process values that are important for safe management. Next, let me talk about case studies for second and third eyes. As second eyes, we provide the control valve maintenance support system. It's a diagnostic software that can visualize, analyze, and diagnose the control valve condition from the parameters that Azbil Smart Valve Positioner provides. For example, position output air pressure, valve travel, maximum friction force, 0-point position, etc. By utilizing positional data, you can prevent unplanned shutdown of your factory and improve the productivity. Also, Azbil control valve maintenance support system greatly improves control valve maintenance quality. Control valves play a critical role in plant operation. So control valve maintenance is needed for safe operators. The left pie chart shows the result from control valve disassembly inspection at Azbil service shop. The chart shows that roughly 60% of control valves were judged to be normal and returned to service after cleaning. By utilizing Azbil control valve maintenance support system, we can do condition-based maintenance. It not only provides early detection of control valves problem, but also reduces the cost of control valve maintenance by about 60%. In a certain factory case study, we found out that the maintenance costs become high, and a big loss by an unexpected equipment shutdown caused by control valve error was avoided by utilizing Azbil control valve maintenance support system. This is a case study where Azbil control valve maintenance support system helped to avoid unplanned shutdown by early detection of control valve poor condition at a chemical company. The user discovered that max travel speed of the control valve suddenly increased for a duration of 2 weeks. Travel speed was low for 3 months. Sliding motion of valve plug had to be smooth. In case of this plant, stick slip phenomenon had occurred by the progress of polymerization at valve inside. Stick slip is a term used when control valve does not operate smoothly due to excessive friction. Stick slip diagnosis uses algorithm to quantitatively detect this problem. Azbil control valve maintenance support system has stick slip monitor charts, like the graph on the upper right. Before completely sticking, this phenomenon had occurred frequently, and the user could discover that too many stick slip data had occurred over the threshold in the monitor chart. Thus, the user could detect control valve failure early. From the stick slip parameter, the user conducted this assembly inspection immediately. On inspection, it was discovered that polymer had stuck on the ground packing, as shown in these pictures. After the overhaul, the control valve operation became steady. Safe and efficient operation was realized by avoiding unexpected control valve failure. Furthermore, Azbil control valve maintenance support system improves the way control valve test is conducted. It helps you to drastically reduce the manpower required for step response test and loop test. For example, if you conduct a step response test for 200 control valve with 2 pattern tests, 400 tests will be required. This will take about 7 days with 2 people using the conventional valve test. On the other hand, if you utilize Azbil control valve maintenance support system, you can conduct the tests in only 2 hours with 1 person. After you click on the display of Azbil control valve maintenance support system, step response test is done automatically. Thus, we can drastically reduce the manpower required for step response test or loop test and realize maintenance cost reduction. Also, the user can start operating earlier than usual. Next is a case study of Third Eyes. Third Eyes learns past behavior for early detection, visualization, and warning of behavior different than usual. With Third Eyes, we provide the online anomaly monitoring system, which learns the neutral state of a plant with fuzzy neural network. This detects and gives a warning of any irregularities. And with early warning system for time series data, we also are able to forecast and visualize future fluctuation in process values that are important for safe management. Online anomaly monitoring system is one of Azbil AI application. It learns various operating patterns from big data and analyzes in the same way as experienced operators and judge to detect behavior different than usual. As for the mechanism, the system utilizes long-term process data that has been collected by the plant information management system to automatically generate a model that has been taught and normal sensor reading and control output from PID controllers. Anomalous behavior from failing or defective equipment, etc., are quickly detected by this model, and notification is sent to operators. This system estimates upper and lower limit depicted by the white lines using Azbil AI engine from process data stored on plant information management system. Blue line is the actual measurement of process data. Alert is announced when the actual measurement exceeds estimated normal range. From our experience, this system detected the abnormality 2 hours before the operator. Also, abnormal readings were recorded 1 week before an experienced operator noticed. This system helps us to prevent troubles due to equipment malfunction in advance. Next is early warning system for time series data as third eyes. There are 3 blind spots of this alarm system. First is rapid fluctuation of process variables before the DCS alarm occurs. Second is recurring deterioration while DCS alarm is active after handling. Third is recurring deterioration after emergency shutdown. These situations cannot be detected with DCS alarm system, and therefore serious accidents, for example, at chemical plants occur. In addition, when accident occur, DCS alarm system are flooded with alarm. Important alarms are buried in the flood of alarm, keeping operator from not seeing them. Furthermore, even though signs of anomalies begin to appear 30 to 150 minutes before the accident, operators and managers don't notice them and can't prevent the accident. If future can be seen or is known, the future can be improved. Early warning system for time series data can detect such as 3 blind spots of DCS alarm system. This system constantly monitors behaviors in important process variables automatically and predicts displays their future behaviors. In the near future, when those process variables are predicted to reach critical control values, future prediction alarm occurs. Also, predicted time to reaching a critical control value is displayed. Those future trends are possibly displayed on large monitors and everyone in control room can notice. Thus, this system contributes to a highly reliable and secure framework for team operation. This is the result of benchmark data verification of early warning system for time series data. In the left graph, reaching critical control value was not predicted yet. In the right graph, this system predicted future abnormal situation and could issue future prediction around 180 minutes before reaching critical control value. So we could see the future. In concluding this presentation, I would like to summarize our major point. Second and third eyes provided by Azbil includes the human situational awareness abilities and helps to improve site safety and productivity. Also, Azbil can provide not only the product I introduced today, but also other solutions, including field devices. Lastly, we provide comprehensive solutions and services from control system to bulb and other field devices. We have the know-how on bulbs and other field devices. So we provide maintenance service as well as control system solutions. We can merge Industry 4.0 and process automation know-how cultivated over many years. Even if computer manufacturers can utilize statistic and analysis technology, optimal solution cannot be reached without knowledge related to measurement and control automation. Azbil is a control manufacturer that utilizes IoT, big data, AI, and more with understanding of processes. If you would like to realize smart factory, please contact us. On behalf of Azbil, I'd like to thank you all very much for your attention.
Thanks, Jun. Up next, we have two speakers from Schaeffler, Chan-Ming Ling, the VP and Head of Industrial R&D and Head of Industry 4.0 at Schaeffler, and Andre Heskamp, the Head of Digitalization and Operations IT. Their presentation will focus on reducing unplanned downtime with condition monitoring and predictive analytics.
My name is Min Ling. I'm the VP Head of Industrial R&D and Industry 4.0 from Schaeffler Industrial Asia Pacific. I also have my colleague, Mr. Heskamp, who will be presenting from the Digitalization Operations team. And our topic today will be reducing unplanned downtimes with condition monitoring and predictive maintenance. So what is reality? Transformation begins with management, a management team that stands behind change towards condition monitoring of machines. 1 billion measurement points are not monitored, close to 100 unplanned stops per year, and production losses equate to more than 3 times the target. So what sets us apart? Our current portfolio already offers many products and services around the life cycle of the rotating asset, condition monitoring, maintenance tools, lubricator services, and all are our essential components. However, this doesn't set us apart from our competitors who have a similar portfolio. What sets us apart is how we combine the individual products and services and what design principles we follow. Digital first, customer and service centricity. We enable that Schaeffler knowledge can be used in one user interface or UI. It's easy. We target non-expert customers and our services can be used with little or no training at all. And of course, the true solution thinking. We enable superior solution value, low cost and unique services because our entire portfolio is built on one architecture and therefore much easier to combine for the customer. So what does that mean? So it means for us, digital is first, the radial focus is on the user, easiness to use without expertise, and of course, the true solution thinking from installation, monitoring and operating, maintaining and fixing towards end of life. 6% of our machines are with high criticality, of which we monitor with online monitoring solutions. The light green here on your right-hand side, 36% are typically unsupervised or route-based measurements and typically used with handhelds. The left-hand side here shows 50% of machines with low criticality. These are typically auxiliary machines such as e-motors, fans and blowers and so forth. This means that 94% of our products can be, 94% of machines can now be monitored with our award-winning uptime solution. This award-winning uptime solution is affordable, easy, and plug and play. Our inner circle here represents products for your core production equipment and critical machines. This is ranging from the ProLink, our Arcanol lubrication, and of course our heater ranges such as the MFT. Products in the middle are for process-related equipment machines that need continuous monitoring of data. They range from the Smart Check, the lubricators here, our Arcanol lubrication, and of course our medium-range heaters. The outer circle are for auxiliary equipment, such as your e-motors, facility fans, blowers, which tend not to be monitored, but can now be easily monitored using our Uptime solution and Concept lubricator products. Our condition monitoring products range from the inner circle, ProLink, Smart Check, to the outer circle, Uptime, and they cover the full suite of monitoring various rotating machinery in the production plant. A combination of these result in close to 50,000 euros of savings from unplanned downtimes in our plant in Vietnam. Our digital pilot plant also uses the combination of Arcanol lubrication and automatic lubricators on your far left. And we've already seen a 25% reduction in maintenance costs by using this. The full condition monitoring solution is accessible with one user experience. From Uptime on the top right to ProLinks, Smart Check, our Concept lubricators, and of course the remote services using our experts to support the customers. I would now like to introduce my colleague, Mr. Heskamp, who will be presenting how these products benefit our maintenance team in our digital pilot plant in Vietnam. Thank you.
Thank you, Ling. Hello, everyone. My name is Heskamp. I'm responsible for digitalization and operations IT for Schaeffler in Asia Pacific. Based on what Ling explained before in her presentation, I would now like to show you how we can apply condition monitoring and predictive maintenance solutions in our factories. And I would like to do this on the example of our digital pilot plant of Schaeffler here in Vietnam. So I'm located here in Vietnam. We have a pretty new factory here, which is in the location of Bien Hoa, very close to Ho Chi Minh City. And here we are producing for our industrial customers different types of bearings. We have a square area here of around 50,000 square meters, and we are producing with more than 400 machines our products and deliver these products to all over the world, to America, to the EU, also of course here in Asia Pacific, but also to China. This plant here in Vietnam has been defined as a digital pilot plant, which means that besides the real production of our parts, we are also focusing a lot on connecting our machines, collecting data, work with this data, and so on. When we talk about digitalization and also have a look towards maintenance, also here we have different requirements with regards to how we want to operate our machines. Of course, with digitalization, with condition monitoring and predictive maintenance solutions, we want to generate the highest availabilities. The higher available our machines are, the more we can produce and the more efficient we can produce as well. Furthermore, we want to use data to also not only react on something that happened in the past, but we will also want to be able to predict something in the future. So we want to understand what will happen with the machine in the next weeks, in the next months, and so on. Besides that, we want to use digitalization as well to create transparency and also a need-based monitoring of our machines and equipment on our shop floor. So what does that mean, especially for our plant here in Vietnam? We've been applying all of these solutions which Ling showed before in her presentation. And you see this here as an example. You see the picture of our plant here in Vietnam. And coming from the top left here, we have applied more than 50 of these smart check sensors on our highly critical machines and equipment. This enables us to collect vibration data, but also temperature data and so on, continuously monitoring these highly critical machines and their data, and also do analysis based on these data. Furthermore, we have applied more than 40 concept lubricators, C1 lubricators, which you see here on the top in the middle, which enables us to have an automatic and need-based lubrication of our critical machines. This saves us around 25% of costs compared to a manual lubrication, where people have to go there and do the lubrication by themselves. This is a really cost-efficient and also a very easy to apply solution for us. And of course, due to its refillability, it makes it even easier to use. Besides that, and not coming only from the smart sensors, which you see here on the left side, we also have applied our easy and fast to apply uptime sensors. So of these sensors, we have applied more than 130 sensors on different equipments, on different facility equipments, based on a very simple and wireless installation. And this enables us also a very comprehensive and mobile monitoring of our equipment. So our colleagues can see on a smartphone app basically the conditions of the different equipments that we have connected with our uptime sensors. All these solutions help us to, first of all, collect data, to create transparency, also in real time to see, for example, on dashboards, the conditions of our different machines. But we can also get alerts if something is not in the desired tolerance. And our people from the maintenance department, but also from the production, can be informed on alerts in real time so that they can do the right actions to fix issues. We use this condition monitoring solutions in our daily shop floor management. So in all of our shop floor management activities, we always have a look on these dashboards, on these condition monitoring systems to really understand in real time what is happening and what is going on our shop floor. Besides that, we can also use these data towards predictive maintenance. So if we understand that there will happen something with the machine in the future, we can improve also our maintenance activities with regards to planning. So we are better able to plan repairs. We are better able to plan also the availability of spare parts. And this enables us to look more towards the future than just reacting on something that happened in the past. And that's also something that you can see on the bottom right of this slide. With this condition monitoring, and especially with the analysis of our condition monitoring data, we are able to predict, for example, machine failures already up to 20 days in advance. And this helped us already to save in our plant here more than 50,000 euro per annum in unplanned downtimes. So here we have a really big benefit. And furthermore, we are now using all these big amounts of data because we are having so many sensors which always collect data to do more advanced data analytics, for example, in anomaly detection and also prediction algorithms. So overall, these solutions have helped us to reduce our downtimes and therefore, as I said in the beginning, to increase the availability of our machines. Summing up and showing you our three main success factors in the area of condition monitoring and predictive maintenance. The first step was for us the demand-based sensorization and data collection through these sensors, then visualizing these data and analyzing this data and coming towards a stage of predictive maintenance. And these all helped us to reduce our downtimes in the plant and increase the availabilities of our machines. That's it from our side. Thank you very much, everyone. And now we are looking forward to your questions.
Next up, we have Faraz Ali, Product Manager for IT and Edge Infrastructure at Vertiv ANZ. First, we'll discuss how automation, machine learning, and the Internet of Things are paving the way for Industry 4.0. Over to you, Faraz.
So hey guys, Faraz here from Vertiv, Product Manager of IT and Edge Infrastructure. Today, I'm going to be talking about smart manufacturing or the Industry to 4.0, or more importantly, the movement or what you need to get to Industry 4.0. Now, before I begin on the concept, just want to talk about the movement or the vision. So whether or not you're aware of it or not, we've been moving from Industry 1.0 and now we're trying to get to 4.0. But what does it all mean? So where we're beginning is we began at 1.0. 1.0 was the whole idea of getting your early concept of industrialization, right? Getting things on an assembly line. And then moving that to 2.0, which was doing that at economies of scale or mass production. When we got to mass production or getting to that level of efficient resources, we said, hang on a minute, why can't we do this at automation? Hence became 3.0, right? Or Industry 3.0, which was the manufacturing or the industry in general, which was the ability to have your robotics or your assembly line to be automated, to be doing things with very limited human intervention. Of course, you do still need human intervention, but it was the ability to have the automation or the computers or your electronics make things more efficient for yourself. So we're kind of here now. And I get the question all the time that, okay, Faraz, I'm at automation, what next? So you've got a data lake, you've got automation. So what is 4.0? So on the right-hand side, you can see the whole concept of your vision, right? So your vision becomes your whole data lake, your processing, your cloud computing, your IoT, your automation stack, which I'll talk about shortly. So it's the ability to take your movement of 3.0 to 4.0 is where we see 4.0 being, right? Being able to convert your data to be realistic and most important, real time. The ability to let automation to become real time, whether it's predictive failure, predictive maintenance, or real time asset management, which I'll get to very shortly. So what does this all mean? So all the time, you see these buzzwords every single time. You see M2M or machine to machine. You see machine learning. You see digital transformation. You see artificial intelligence. Sometimes all of these words get floated out there, but at the end of the day, Why do they exist and what they mean? So you've seen now Industry 3.0 and 4.0, but what does machine to machine or machine learning mean? At the end of the day, machine to machine is the ability to have literally one machine talk to another machine with very limited human interaction. What that improves is what we call latency, the ability to get from data from one point to another and process data very quickly from one point to another. But then, okay, so I know what machine to machine means, going from machine 1 to machine 2. But then what does machine learning mean? So think of a feedback loop where we know as humans, where we perform a task and we learn from our failures. Very similar to machine learning. Machine learning is the ability to go, hang on a minute, I processed a task. I've learned a better way to process this task. So next time, I'm going to do this task better or quicker, i.e. more efficient, right? Which is the whole concept of machine learning. Being able to provide that feedback loop to say, guys, I did it one way first time around, but I think I can use the resources or I can use the processes to do it quicker by another route. And eventually you get to a point where machines are working indirectly faster than human interaction, which is where we want to be, right? And then you have IoT and IIoT. These buzzwords are out there everywhere with digital transformation. So we know digital transformation is digitizing your data, going from what you think is textbook or writing down and digitizing it. The improvement in digitizing it is the ability to have it, one, always accessible, but two, being able to use that data for future use or efficiency. Hence the words IoT and IIoT. So IoT being the Internet of Things. What does that mean? A thing is sensors or data acquisition, the ability to have something record data for you, okay? So imagine having something as simple as a door sensor or a temperature sensor. All these two devices are doing is saying, is my door open or closed? Or is my temperature too hot or too cold, okay? This is deemed as a thing, but what makes it an internet? Internet means it's connected back to the network. So it means, imagine if me was a temperature sensor. I could say, hey guys, my temperature is a particular X value. If I get too hot or too cold by my parameters, I'm gonna let someone know in the internet such that that device or process can do something about it. So imagine a machine that's talking to a temperature sensor to say, hey, temperature sensor, if you get to a particular temperature, let me know about it so I can do something about it. And this is the whole idea of artificial intelligence or proactive failures or proactive maintenance, knowing when something's going to fail or knowing how to fix something if it's about to fail or is not being as efficient, okay? So this is our concept of moving to that industry 4.0, moving away from the concept of automation and moving to that concept of proactive action, being able to take that data or that data lake and do something about it in real time. So, well, okay, so all these buzzwords or data exist, but why is it here? Why now? Why not earlier? The reality is it has been here. It has been here for a couple of years, if not more, 4 years, 5 years. But the key concept here has been literally the increase of data or data volume. So across these key 4 points you see right here in front of you, you've got, us as end users consuming more data, accessing more data, okay? That in here in itself, you can imagine how much you're relying on your smartphones, on the apps on your smartphone, virtualizing data, moving to the cloud. All of this doesn't just magically happen. This has to be stored and computed somewhere, okay? Then we have newer industries informing, like smart transport, smart manufacturing, smart retail. All of these are starting to use some level of human and machine interaction. It's starting to get machines to do some of that level of process for us. And of course, as this starts happening, we're starting to transfer some of that, the digital instructions into the physical world. So early days here in Australia and also in Asia is the movement of smart cars, smart parking, smart councils, right? Moving instructions into the real world, trying to get technology to do the work for us. So as this starts happening, as latency starts decreasing, as demand gets higher, we are going to need this more and more. So as a result, you can see this kind of curve, right? Where you go from your value against your analytical sophistication, i.e., how much do you want to optimize before you see any real value? And you can see each of these touch points across this level of optimization in terms of how meaningful is it to me, not only as a customer, but as an end user, right? Going from a business in terms of operational reports, being trying to get real-time information so you can improve your ERP or your resource management, be trying to get real-time or meaningful dashboards, i.e. financial dashboards, being able to find forecast in terms of what am I going to order, what am I going to deliver, what am I going to have in 3 months or 6 months, right? Part of your ERP system. And then that holy grail or the end goal in terms of what are we going to do in terms of predictive analytics or predictive failure. So let alone learning how to go in and make sure it doesn't fail, but imagine being able to tell your customer that, hey, in 3 to 4, 5 or 6 months time, this particular endpoint is going to fail, or we predict based on previous data it's going to fail. Imagine how powerful that's going to be the customer, where you go back and as opposed to going, hey, we have to come in monthly or quarterly, half yearly or yearly to do proactive maintenance. How cool would it be if you could go in there and say, hang on a minute, we'll only come in when we predict something's going to fail, heavily reducing the OPEX cost back to your customer, okay? So improving your supply chain, improving your service into the predictive failures, and of course, improving your asset management or optimization. So now a slightly more techie slide. So I get asked all the time, you know, Faraz, this is all good and all, but how do I deploy it? How do I implement an organization? I'm a manufacturing or an industrial business. How does it work? So on the left-hand side there, you can see a complete pyramid stack. This is a typical pyramid stack you'll see in most organizations, right? You start at field level and you go all the way up to your management level. But what does that mean? If you move over to your right-hand side there, you'll see me getting slightly more technical in terms of the expanded setup. Okay, some of you may not be aware of this, but there's a lot more to it than meets the eye in terms of going from a sensor or a logic controller all the way up into the organization to make a real-time decision. What this kind of means is, you know, you've got some sort of logic controller at the very bottom. That is the kind of brains in your assembly line to say, I am processing X, Y, and Z operations to do a particular function. I'm going to push the information up to a SCADA system. Now that SCADA system is an overarching monitoring or management system to say, I'm going to look at my entire plant and I'm going to see what plant is doing and bring all that data in. All that data eventually gets to what's called an MES, okay, or a manufacturing execution system. At the end of the day, the MES system is in charge of things like your set points, your operating instructions, your level of maintenance, your QC, your resource scheduling, right? At the end of the day, this is what tells the device what to do. Once it gets that information from SCADA, MES goes, okay, I've got real-time info, I'm going to do something about it. As soon as MES records its info and says, I need to do stuff, obviously you're going to need an order or a resource tool to actually order it. So the MES tool pushes it up to an ERP tool, right? Or enterprise resource planning. At the end of the day, this module is designed to go, okay, I've got real-time demand from my supplier, from my employer, and at the end of the day, I need to make sure my supply meets my demand, or most importantly, my demand meets my supply, okay? So unfortunately, up until this point, we're seeing a lot of businesses being very reactive, i.e. we see a large amount of demand, and then we put a very large supply order in to meet that demand. Why not look ahead of time and go, I can see what's happening on my assembly plan, so I should proactively bring in more orders to fulfill my level of demand, right? And this is where Industry 4.0 or your smart manufacturing, smart factory, smart retail all kind of comes into that single picture is why can't I get my SCADA system to talk to my MES system, which then talks to my ERP system, and eventually all goes up into some level of cloud, right? And goes, why can't I get this all talking together that at any point in time, I can look into my organization and say, if I'm looking at my ERP, my MES, or my SCADA, I know what my business is doing real time, and I know what my potential lags are. This is where we want to be, and this is what the automation pyramid is trying to achieve. Going from your field level to your control level, which is saying, I'm going to do something about it, to your supervisory level to say, I'm overlooking it to make sure everything's okay, up to your planning level to say, I'm going to do something about it, and finally your ERP level, or even above that, the cloud level, to say, I'm going to make sure you have the resources to support it, whether from a ordering raw materials perspective or ordering for a purchase order in terms of processing a demand perspective. Okay. So where have we at Vertiv seen this scenario or a real case? So a cool example here is Tasmanian salmon or tassel. So we had a unique pain point via our customer here, tassel or Tasmanian salmon, where they were harvesting or processing salmon, okay, via pens. And at that point in time, they had operators saying, it's good, but we're using a gut feeling or a knowledge in terms of when to feed the fish and when to harvest them. They said, why don't we take it one step further? That these 19,000 fish per pen over these 19 pens, what if we went and had temp sensors, water flow current sensors, humidity sensors, salinity sensors, you know, the visible sunlight, all of this, and we can get optimal levels of when to feed the fish and when to harvest it. And the amount of feed they saved was so significant in terms of getting real-time information all the time to know when to feed them and when to harvest them was absolutely immaculate. Where we got to the point where we said, guys, the whole point of fishery is to say, have your salmon in there and make sure that you're providing your feed, you're harvesting of your result of your feed at your optimal point, right? Using real-time data, active data. So getting your sensors to feed that SCADA system feeding the MES system, which is actually controlling the feed. But most importantly, that MES system is talking to your ERP system and say, guys, we're running out of salmon feed, order us more. And it'll automatically come in to make sure you're never short, right? Proactively available. And then you eventually get to the point where you're building this ecosystem to say, I've got a whole neural network to say, I can bring a salmon from all the way from when it's a very young or an egg and get to the point where it's ready for human consumption or where me as a business is going to generate revenue. And that's most powerful because when you have eyes on your entire process, one, you can improve your operational efficiency, but two, obviously reducing your cost and increasing your operational margin. And then as a result, we as Vertiv got in there with a micro data center and said, guys, you know, well, all these sensors are going to be going back to some level of data. That data needs to be processed and stored and then eventuated and sent back to real-time information. And of course, then we deployed our smart cabinets here, as you can see on these two images on the right. Okay, so there's actually 10 workstations living in this room, powered by 5 of our micro data centers of fully integrated smart cabinets. So this is ensuring that each of these operators sitting in front of these 11 screens, reminding you that these 11 screens are looking at things like temperature, humidity, salinity, water flow currents, visible sunlight, weather, etc. Ensure that one, the fish were in optimal conditions, but two, the fish were not being overfed, because the biggest cost in fishery is the amount of feed to grow your salmon before you harvest, right? So we increase the productivity and increase the cost savings. Second example here is then the whole concept of the edge. So we hear the concept of the edge. I go all the time and go, Faraz, I hear edge, I hear 5G, I hear IoT, but what does it mean? So 5G has obviously been coming on the radar for a very long time now. And this picture here exactly represents the importance of 5G. So 5G is the ability to have very, very high access of data. What I mean by that is extremely low extremely low latencies with the amount of bandwidth or latency available, okay? So obviously the trade-off is your towers are much closer together, which our telcos are meeting in terms of infrastructure at the moment. But the important thing is you can send very, very high bandwidths or very, very high levels of data at very, very, very high speeds or very low latency. So what does it kind of mean? So we know in Australia or globally, we're trying to look for things like renewable energy or sustainable infrastructure. So whether it's wind, whether it's solar, whether it's hydrogen fuel cells, whether it's hydro, at the end of the day, we're trying to make sure that we're meeting some level of renewable energy. In this particular example, we obviously used a mix of 5G and renewable energy via solar. Okay, so as you can see in the images here on your right, we've been working together with a particular large telco here in Australia and going, hang on a minute, I've got a pain point where I'm in a remote site. That remote site's not going to have access to any type of grid or real-time infrastructure in terms of power. So I need renewable energy. I need such that during the day, my renewable energy can meet my demand, but overnight, when there's no solar, I have enough battery backup to provide it such that it's up 24/7. And we actually went and designed a solution for them. So we provided the solar panels. You can see the solar array there, as well as your wind. So we got hybrid of solar or wind. So at any point in time, one fails, the other one picks up. But we also had a large battery system to support it overnight. And what this kind of meant was, it was a perfect solution for one of our large water transport customers, in terms of they had boats traveling through water systems or waterway systems. And at the end of the day, they didn't know how much impact the traffic or the speed of the boats had on erosion. And they were wavering down the water banks. And the water banks had a problem because not only was it unnecessarily filling the banks up with dirt, sand, and other types of pollutants, but it was actually degrading the land around it. So they said, if we can start using 4G or 5G cameras to start doing real-time monitoring to see what type of boats are going through and how quickly the boats are going through, we could start getting automation in terms of software to measure how quick was boat X traveling through and how many boats traveled through in that hour. And then we could cross-correlate that data in terms of the erosion to work out how much impact do these boats have on your data bank erosion. So as a result, we here at Vertiv then designed this solution here, as you can see. So we had our 4G or 5G access connected to our cameras, which is then backed up by some level of batteries. And then the batteries were charged by a solar array, okay? We also had some wind turbines as a backup, but the primary was a solar. So the importance of this is to say, hang on a minute, like I've got some sort of, if you got manufacturing, right? Retail, transport, industrial, whatever it is, I know we're moving to sustainable. So why not go to solar panels or hydrogen or wind? All of it is completely possible, as obviously as long as you've got your battery set up in terms of your critical infrastructure, and then you've got your camera set up for, in this case, your real-time surveillance. Of course, if you don't need the cameras, then that's fine. But in this case here, you can see particularly, we had our network, as you can see there in purple, and then your orange in terms of your power, in this case, your DC power. And this gave us our ability to give a real-time informational access to the data to provide smart level access and proactively do something about it. So I'm going to kind of sum it up here in terms of what smart manufacturing, retail, industrial is. What does IoT mean, or what does IoT mean? What does digital transformation mean? And how this kind of translates into real-time occurrences or use cases here, where we go from one side of the spectrum, where we're using real-time data to do smart level of industrial manufacturing or agriculture or aquaculture, and on other side of the spectrum, going from smart transport. As you can see, your boats traveling to the waterways, or even smart industrial, if you like to extend that far, or most importantly, renewable. Thank you very much. If you have any more questions, please do reach out to me. We do have 2 QR codes here that you can scan and get access to in terms of what you're regarding to need in terms of your scaling, or regarding in terms of what your edge infrastructure is. But at any point in time, you're more than welcome to reach out to me if you have any questions. I'm more than happy to help you in terms of what kind of solutions we have and part of portfolio and what we can do to help you journey from that industry 2.0 to 3.0 or that 3.0 to 4.0. Thank you.
Okay, thank you. Now we're going to go into the Q&A session. Okay, thank you. Questions do we have? Okay, to Ling or Andre. Does Uptime digital platform, is that able to export data to a third party platform like an MES? Hello, I can't hear you.
Sorry, can you hear me now?
Yes, I can hear you now. Yes.
Okay, I can definitely answer that. So what we wanted to explain with Uptime is we have analytics on our cloud, and the data that can be transferred is just a vibration data and temperature data that is to a REST API that can be sent to MES and SAP if needed.
Okay, great. Okay, my next question is to Azbil, Jun. So, yes. So what safeguards will be implemented in the factory of the future to prevent production that is based upon unintended action or information?
Okay, thank you so much for the question. Hello, everyone. I'm Jun Watanabe from Azbil Corporation. So to prevent unexpected production or accident and improve the safety and productivity, I think two kinds of safeguards will be implemented in the factory of the future. First, safeguards will be the implementation of optimal maintenance based on equipment diagnosis by high-performance sensors. In recent years, almost instruments in the factory are able to have high-performance sensor with a lot of parameters related with the diagnosis. So by utilizing the parameter with digital communication, irregularities in instrument will be detected at an early stage. So as a result, unexpected shutdown or accident of the factory will be prevented and the productivity will be improved. So I think utilization of the parameter and early detection of irregularities in instrument will be normal in the factory of future. And as for second safeguard, it will be utilization of AI and big data of the factory. They enable to detect symptom abnormalities and predict future changes. So from now on, this kind of technology will be increased more and more. But what is important in the factory of the future is to understand that the knowledge related to measurement and control automation will be needed as well as these technologies to utilize AI and big data of the factory for safe operation. So I think these two kinds of safeguards will be implemented in the factory of the future.
Okay.
Thank you.
Okay. Okay, I've got a question for us. What do manufacturers need to know about their data moving to the edge? Because traditionally people think about data living within a data center, now it's increasingly moving to the edge of the network. So what do manufacturers should be aware of? What do you want to sort of highlight in terms of that?
So, I mean, the main drive of the concept of moving to this edge or moving the data closer to us is the whole concept of having quicker access, right? So if the whole need for the edge is we just need stuff quicker. So Everybody has Netflix, everyone has YouTube. Imagine that buffering bar, right? People hate looking at that buffering bar. Every time they see it loading, people turn it off. Or I've seen, I've done many surveys, and within 10 to 15 seconds, people go, okay, I'm going to opt out because I've seen the loading bar and it's not enough. So vendors are getting more and more pressure to say, we need real-time access. And this is not even me talking about futuristic things like self-driving cars, which need, real-time access. This is even minuscule things. Imagine in your business today, how frustrated you get when you're trying to access something in your own business network and you can't get it quickly enough. You throw your arms in the air and go, I can't get my data as quickly as I can get at home. So my business is too slow. So I'm going to chuck a fit. And this is the real-time issues that our business is having today in terms of this whole edge or having data quicker to us. So these days, when we're looking at 4G or 5G, is how quickly can our own consumers consume it? And it's putting pressure on our 4G or 5G retailers or supermarkets to say, guys, we need data closer to us because our consumers have the stupid expectation that we need data quicker. They need it now. Millennials like me go, I can't afford to wait more than 30 seconds because I'm going to throw you away and find something quicker, right? And that's the whole concept of the edge. So the reality is going to be, I don't care whether you're a retailer, whether you're a manufacturer, whether you're a supermarket. If you can't do anything real time or now, you're going to get irrelevant in the next 2, 3, 5 years, right? And that's the truth. Like, I don't care what people tell me, but if you can't provide me that data now, you're going to get irrelevant so fast that it's silly. So it's so important today to have that data near you or access to you that our next generations of today or tomorrow can access it. And that's the edge. That's the reality. That's the tomorrow. And that's what we're trying to do here at this point.
What just a follow-up question to that, what applications can we expect from this transition to the edge? Is people talking about augmented reality and then some of these new applications which we're seeing. So over the next few years, where do you think this go? I mean, where do you see this going, and what new applications can we expect?
Sure.
Manufacturers expect.
Yeah. So what's going to get to us? So I've very early already started working with supermarkets, retail companies, where imagine you can walk into a retail store, right, or a massive mega store or supermarket, and imagine you got this virtual guide walking next to you. It's telling you what you can buy, what the latest specials are. And this was happening in real time. To have this type of infrastructure to supporting you means that that kind of data center equipment is happening nearby you. Imagine how cool it is if you can walk into your mega store, your supermarket, and you've got this virtual male or female standing next to you, walking by you going, hey, I've got this cool special. I've got these data available to your personality. Let me walk you over to the store that can tell you what you can consume at this real time. And we as consumers haven't accessed this at this point. At this point in time, we go, oh, I know, I love handbags. So I'm going to go to the store at level 2 that sells handbags. And after that, I'm going to go to the food court, eat my food and walk away. Cool, right? But imagine having this retail tour guide who walks through with you and goes, I know your personality type. I know you buy X, Y, and Z product. Let me walk you through with it. They've got this certain special. And you as a consumer goes, oh my God, this is amazing. I've got this tour guide with me that's personalizing my buying journey. But all this to happen is not going to happen in real time, right? This is going to need automation, servicing, networking, all in real time. And these retail stores are going to really have to think about this and go, how are we going to make this realistic and approachable? Because I can go to sleep and think about this in my la-la land. But to make this happen, we need to work with so many different vendors, so many companies, partners to make this a reality. And unfortunately, this is where our consumers want us to be. And this is where I see smart retail, smart councils, smart cities moving to. But until we kind of put our foot into motion and support this, I don't see us going this way. So, I hear the words edge, I hear latency, I hear real time, I hear augmented reality, I hear virtual reality. But until we do something about it, these are just going to be buzzwords to me like Faraz. And until we all work here as a community, I don't think we're going to get there.
Okay. Okay, good. So to Schaeffler, so to Ling or Andre, how reliable are the alerts generated from predictive maintenance?
So that's back to me, product level. So we had shown 3 products. The Uptime, which is a wireless solution with AI analytics. We have ProLink, which is a multi-channel system, and a Smart Check, which is a single channel system. All of our products have learning modes. So they have different learning modes, which is needed in order to determine the alarm limits for each of the applications. So each application runs differently, depending on, whether or not I see someone had asked about food industry and retails and things like this. It's running at a different condition, running at different levels. And this alarm limits is learned and then put into an array. And there we will then give the notifications of the alarms to the users. Now, on top of that, there is an algorithm, a Schaeffler algorithm behind the scenes, which is monitoring if the alarm is what we call fake, or it's not real, or it's something that's just come up, but it's going to go away in a few days. We monitor this as well, and there's an algorithm behind the scenes that monitors this. So hopefully, Mark, I've answered your question.
Okay, great. I have another question for Schaeffler for the Q&A. So, have all these systems been tested outside of a clean environment or the mining industry?
Was that for Schaeffler or was it for Azbil?
I believe it was for Schaeffler. Was it? I have it down for Schaeffler, but I'm not sure.
I can definitely answer, and I think that came from one of the participants. Okay. So definitely for Smart Check and ProLink, it's been tested for mining. With Uptime, we just released this in October. We're going through some trials in mining to understand if it works in the mining industry. Kindly note that this Uptime sensor in the gateway is at IP69, which means for dust ingress and so forth. It should technically work, but we definitely need to test this out with our trials and pilots.
Okay, thanks. So I've got one question for June from Azbil. So Singapore is working toward working with the World Economic Forum on its Smart Industry Readiness Index, which has helped guide manufacturers towards adopting smart factory principles and towards Industry 4.0. So what advice would you give in terms of best practice would you recommend to manufacturers looking to embark on their Industry 4.0 journey?
Hello, can you hear?
Yes.
Okay. Thank you for the question. Embarking on their Industry 4.0 journey means realizing smart factory for improvement of safety and productivity in manufacturing site. So from our practices, we would like to recommend to promote the utilization of retail equipment data and AI and big data for smart factory. So as for utilizing detailed equipment data, especially as I explained today, control valve diagnosis is more effective for safe operation. So because control valve play a critical role in plant operation. So by control valve diagnosis, even non-valve specialists could find out the duration of control valve. This will be more important in the H2 camera-like retirement of experienced operator, future decline of working population, and new normal operation due to COVID-19. As a first step, we recommend to use the latest instruments which have diagnostic parameter in your factory as much as possible to realize smart factory. Then as for utilizing AI and big data for the factory, for example, our early warning system for time series data is our product enabled to predict the future behavior of process variable from the past time series of itself. So the past time series include the inexplicable uncertain disturbance and internal condition. So even if there are unexpected action and phenomenon, it's enabled to predict the future abnormal situation. These technologies inherit and transcend wisdom of experienced operator. So by utilizing them, and it helps your decision making. Yeah, so we will recommend to implement them in the factory for realizing smart factory. Yes,
Okay.
thank you very much.
Okay, thanks. So we have a question on any case studies, any examples regarding a food processing factory or a garment factory moving towards, I guess, adopting smart technologies. You said the products are not always standardized like industrial products. So can Schaeffler answer that, or some?
Definitely, I can. So we have pilots, what was considered pilots, but also trials with F&B customers, FMCG customers in Europe. We will be expanding this in Asia Pacific. So currently our focus is on cement, pulp and paper, and these industries. So when I said before that we know it works, it's because I've seen pictures of uptime with full of dirt in the cement industry. It's very filthy, it's dirty, we know it's working. We've tested it in very harsh conditions, not in all conditions, but in majority of conditions. So we definitely know that in a food processing factory, potentially in the non-areas, like say, that's not clean room, definitely uptime would be a solution for your auxiliary machines.
Okay, great. We also, we have one question on learning mode. I think you mentioned a learning mode just now, a while ago. So does it take into consideration if there's only one impact or a couple of impacts, which is not true? So yeah, maybe just provide more information on the learning mode if you could. I think someone's interested.
So that's a very good question from Mr. Lee here. How does the learning mode take into consideration if it's only a once impact or a couple impact? Okay, so depending on the product. So if you're talking about uptime, it takes 15 days plus 15 days learning mode. We would check the data to make sure that it is at a normal operating condition. If there's an instance, and we've seen situations where we put uptime onto a machine and there's an immediate error, or we see that the peaks are high, then we will reconsider checking the system, making sure that there is no lubrication issue or bearing issue or anything like this with the FFTs and the bands and the harmonics. Then we will restart the learning mode again. With the Smart Check and with the ProLink, there are different learning modes in these devices, which is different from uptime. So really, I suggest that we can talk to you about this separately, or you can engage a Schaeffler expert, because the conditions are unique to that application, and we need to be careful with the learning mode. So this is why we always encourage to engage with a Schaeffler expert in this area, especially one that has bearing and rotating machinery expertise.
Okay, great. One more question for Schaeffler. Does your product interface with existing systems such as ERP, SCADA? I mean, how does it work with this existing hardware overall?
Can you please repeat that, Mark? Sorry.
Yeah, how does your products, how does it interface with this existing legacy hardware or existing systems like ERP, SCADA, etc.?
That's the golden question, or the question that we're all trying to answer, right? Mm-hmm. So with our Vietnam plant, it's a greenfield plant, but there are some brownfield equipment, as Andre would confirm. Yeah. What we had to do was use connecting devices, intermediary intermediary connecting devices to connect our uptime, ProLink, or Smart Check. Now, with regards to the type of equipment I showed in the circle, there are different types of equipment and different products that need to use to monitor the rate and the vibration and also the temperature and so forth. So this is something that OSO and Schaeffler expert can help the customers to decide what is best for that machine, for that application. But in terms of connecting, I think the question was connecting to SAP and MRP system again. Our other products can also use OPC UA or MQTT to the cloud. So we can do cloud to cloud or OPC UA directly to SAP. It is up to the customer to decide this. This is how they want to see the data in the control room and perhaps even engage the work orders in SAP. So this is important that the customer informs us so that we can ensure that the right data is being sent to MES or SAP system.
Okay, thanks. I think I'll take one more question. We have a number of questions for Schaeffler, but I don't think we have time. Let's see. I guess for Industry 4.0 technology, it can be done remotely, right? That's one of the questions in the chat. Let's see. Are there remote tools for smart factories? Basically, I think he's asking. Do you see the question?
Who's the question for, Mark? Sorry.
It's for Schaeffler. It's for Schaeffler, I believe.
Okay, sorry. I thought it was for Faraz. The question here is about open by remote, technology by remote. Is that right? There's two questions about this.
Yeah, or Faraz can answer as well if you want.
Okay, so currently we can connect uptime, condition monitoring tools, uptime, Smart Check, and ProLink to your device, tablet, Android, and iOS. That's not a problem. It can also connect to a desktop. That's also possible. It is using a mesh network, so it decides on power on the different sensors, and it sends the data through a gateway, and the gateway decides how and where the sensors are sending the data. So this kind of remoteness is possible. However, it is, and then I think Faraz mentioned this, it depends on your signal in the factory. This is very important. Some factories only have Wi-Fi. They don't have very good mobile signals. And we've experienced that in our plant in Vietnam. There are ways around this, and we've managed to solve majority of the issues that we've encountered with poor connectivity and so forth. Not all factories have the right connectivity, and this comes back to infrastructure. And for us, we'll probably confirm that the infrastructure is very important in terms of Industry 4.0. That basis is very important.
Mm.
Yeah, correct. I mean, just to kind of elaborate on that. So at the end of the day, it's great that you've got, you've got your network and you've got your system set up. At the end of the day, irrespective of where you are in your country, it comes down to connectivity and access. And, we've got businesses looking at 3G, 4G, 5G, right? But all this is as good as your access or your infrastructure available. And there's no point having the state-of-the-art infrastructure or network available to support your system if you can't remotely access it. So what's the point of having, your architecture set up such that it can't send you a simple email or SMS alert to say, hey, I'm in trouble, or hey, I need help, and to send you this alert. So, I mean, we're a little bit lucky here in Australia that, we've got gone are the days of 3G, and we're looking at 4G, and even customers saying, oh, we don't want 4G, we want 5G, right? And it's a nice to have, but we can totally understand in other regions, 3G and 4G is just the absolute minimum. And that's where we need to start working with our carriers to say, this is the absolute minimum connectivity infrastructure to support us. Because like Schaeffler's just kind of said over that, we can have the best platform or support available to support your infrastructure. But if you can't even see the thing, what's the point? If you can't see your own dashboard or your dashboard can't see you, tell you. Imagine if something can't tell you I'm in trouble. Or imagine you can't receive an email or SMS alert to tell you, hey, I need help, or my alarm or threshold's in trouble, and you can't see it. Then what's the point? Because the whole concept of this movement is this proactive alarming to tell you I'm in trouble, I need help, do something about it. So I think it's so important that we work our infrastructure with our access and have them both kind of talking to each other, working together. And until this kind of works together, it all kind of falls apart. So totally agree with that remote access question in terms of make sure that your fundamental infrastructure on site works, but also we're going to make sure that access or the architecture to see it also kind of works hand in hand.
Okay, great. Just one quick question, I think the last question from Nick Lee. Can data generated from the uptime, be sent back to their own database or instead of the Schaeffler cloud?
That's a very good question, Mr. Lee. At the moment, uptime, the data needs to be sent to our uptime Schaeffler cloud. That is a given because of the way it's been set up. However, what we can do is send the data through REST API to your own database. That's something that we're working on, and we're trialing this with some of our customers in Europe, and we hopefully will bring that to Australia and also to Asia Pacific region very soon. That's really in the near future, so I'm not going to give a date, but it's coming.
Okay, great, thanks. Okay, so that's all the questions for now. If there's any more questions, attendees can reach out to me via email or to the participants as well. So thanks for your time today, and yeah, we'll be in touch. So thank you to the participants as well. Thanks. Okay, bye-bye. Bye.
Thank you very much.
Thank you. Bye-bye.
Thanks, Mark.
Bye-bye.
Bye-bye.